then you guys will have time to work on it and probably be done with it. Spencer, what's 4.1 on?
Interpretation of derivatives and context.
Oh, that's a lot of words. That's a lot of words. What does that mean?
I don't know.
Oh,
What do derivatives mean?
there we go. Interpretation is literally just like interpreting the actual words into symbols and or symbols into words. This section is here only to make word problems easier. So rather than trying to learn everything all at once, because in the past we've done that where they're called related words. They're just going to be word problems. And if we go straight to the word problems, trying to do everything at once kind of feels difficult. So this section is only focused on the wording and translating. You can read this whole top part if you want. It's basically things we've already kind of covered, like this is just like notation of things, like how you write to take the derivative, which you should already be used to by now. The only thing that you wouldn't be used to is possibly down here. I can't remember if I've ever written it like this with the line in front of it. Yeah, thanks. So function notation usually works super easy because you're used to that. But if you have an implicit derivative, you can't use function notation. And so what you do is, after dy dx, which represents f prime or derivative, go in the back wall if you want one, you put a line and then you could say what number you're plugging in. So that's going to be a common way of doing it. And so going over this is basically just because it's going to be written like that in some problems, and so you would understand what's being said. So even before reading this sentence, this is saying dv dt at time equals 3. The answer is -2. Okay. So it says Sean is cleaning out his saltwater fish tank and needs to drain some of the water in order to adjust to the saline levels. If the volume of the tank V is in gallons, is being drained over time, T in minutes, what is a meaningful interpretation of the following statement as it relates to Sean's fish tank? That is an awful lot. Let's start with dv dt. So the variables that are written there specifically tell us what the label is going to be. And that's going to be the most important thing for you guys to get when we switch to word problems. So the fact that volume is on the top, what was the units for volume? Gallons, okay. Now I'm just writing this off to the side. It's not like that's how it's actually reading the problem. And then time was in minutes. So if it says dv dt, I know the labeling of my answer is going to be gallons per minute. Like that is specifically how we figure out what it's going to say. So what does an answer of -2 mean? Okay, so it's losing 2 gallons per minute.
Over 3 minutes.
Not over 3 minutes, but you're right.
At 3 minutes?
Yeah, losing 2 gallons per minute at the 3-minute mark. I mean, mark might not be the right word, but we'll call that Midwestern lingo. But the negative, they frequently won't say -2 gallons per minute. Sometimes that's annoying and sometimes not, but they frequently will say gaining or losing to indicate positive or negative. I don't know, are we okay with that one?
Yeah.
Okay, I mean, this is all we're doing the entire section, for the most part. So my goal was to just go over a handful of questions with you guys and then let you go and get the work done. I don't know if you noticed in Schoology, but I tried doing like I talked about yesterday, where I made sure to have the correct due date on the homework to see if that would help, rather than just putting it in as I put it in. So the due date is the 21st at 3:06. Okay, so the Alberta tar sands are one of the biggest oil reserves in the world. Yet extracting the fossil fuel costs more than the profits made. If the cost C in dollars to extract a barrel of oil is losing $3 on every barrel, write the derivative. Ooh. Okay, so let's start with the actual data, or whatever we want to call this, that we were given. Like, they told us that information. The labeling on that would tell us how the derivative should be written. So, you know, like dy dx, dv dt, like the one we just had. The derivative is going to be written with two variables. Each one of them will have a d in front of it. My guess is you could probably write the answer before the derivative. What should I write on the right-hand side? Would that help?
Negative.
Okay, so -$3 per barrel. I was trying to question that. There's only one L, isn't there? I know it's written here.
Yep.
Okay. So what am I gonna write over here?
DCDV.
DC, so the cost, and then per barrel. So it has to be whatever variables you choose for that thing, right? Up here, they told us cost, but they didn't give us a variable for the barrels. I'm assuming they didn't do that so to kind of give away what the derivative would be. That's all it's asking for us to do. You don't theoretically have to put the label there, so the dollars per barrel doesn't have to be written. I purposely was doing that to help me write this though, like those two tied together. Why don't you guys see if we can do the second one? It feels weird without anybody here. This is smaller than R&R is gonna be, I guarantee you. 9? 9? No, that's not right, is it? That's 8, 9, 9's gone. You guys are 10, I think, right? 4, gone. This might take a while. 3, gone. 2. What'd you guys get? Ooh, you don't sound super confident. Do you want me to guide you through it? Okay. So 790 is obviously the number. Okay, I was gonna say for this one, I honestly don't, it doesn't really say whether you're losing or gaining. So I think the way they're measuring this one, I think it would be positive, because I think the focus is on how much it's losing, or, you know, whatever it be. So I don't know if a negative would even be needed, but not a big deal. Okay, what's the label on it? It literally tells you.
Like cubic meters per day.
Yes. So the word per is gonna be the dividing line. So cubic meters per day. I mean, it has to say somewhere what the information is. So the cubic meters per day is 100% going to be what we label this. Cubic meters, what kind of a measurement is that? I don't know how to describe it. Yeah, okay. It's gonna be like volume, length, what else would there be? Area,
Mass. She said mass.
we're not that technical. Which is actually kind of weird because it's super technical class. I don't think we've had a single mass one.
So the variable does matter, like what you do?
We could call it whatever we want. It's just whatever it stands for. So we're just gonna use variables that are normal. Like, cause all the scientific equations, you generally already know what those variables stand for. We're gonna use the same common ones.
Cause like I just did M over, like DM over D.
What does M stand for?
I said meter.
Then no. Cause meters is just a length. And this one has to be a volume. So this would be the change in volume compared to the change in, we could put days down here. I guess I didn't even think of that.
For time?
Yeah, frequently time is gonna be the most common variable, but you 100% could call it days if you want. Like, the fact that we wrote days over there means you could call it days here if you want. My guess is you'll see time as the most common one. And then just days is kind of like the measurement of time. Okay. Do we need to do the gorillas one? Should we move past it? Oh, wait, do you guys just wanna try that one quickly on your own? Sure. And yes, you're gonna find that the questions on the AP test are always strange situations. One year was how fast they could stock bananas on the grocery store shelf. And so the related rate was on the rate of stocking bananas. Like it's just odd situations every year. Another one was on baked potatoes. I think it was the change in temperature of a baked potato. This was not a very good sentence. It doesn't really tell you its years, but it infers it when it talks about during 2003. So, the change in population, if you wanted to say gorillas, sure. Change in time. Sure. To be honest, when you're writing out word problems, you can label things however you want. We usually just try to tie them together. But absolutely, as long as you get that they go together, that's fine. Okay, I'll do this bottom one last with you, just because it's weird. Okay, over on the side, yeah, it's about an alien population. Let's just go with it. And in fairness, I'm sure writing these questions is kind of weird because you have to come up with different topics all the time, like faking the moon landing. Okay, so population recorded in millions of aliens per year. Okay. Now, I write aliens per year on the side. However, aliens, the variable for aliens would be P, because we were already told that. Population. The years would be measured in T, because we were told that. Okay, so this is the original function. I actually kind of wrote that wrong, because I already wrote the derivative. That was my fault. I wanted to write that just so we had it written down somewhere, but whatever. Population is just number of aliens. Over here, the derivative is where you talk about how fast it changes compared to time. So that's where I kind of jumped the gun on that one. So the derivative of population is going to be how many aliens per time unit. So for this one, 0.5 means we're going to have 0.5 aliens.
Like million
I don't know, did we say millions?
Yes.
Yep. 0.5 million aliens per year since discovery. And then the 3 represents 3 years after discovery. So 0.5 aliens per year, 3 years after discovery. And this is where these questions start seeming kind of weird because we're just trying to label stuff. Did I write it wrong?
Doesn't the slope of 3 mean the rate of change at year 3? So
The slope is 0.5. The 3 is going to be the t that gets plugged in
doesn't that mean they're like,
at the 3-year mark.
yeah, they're like halving their population? That's,
It's 0.5 million aliens per year, so it's 500,000 aliens. Don't worry what it stands for. It's kind of stupid.
Is the 3 years?
Would it be 0.5 million?
Yeah. I didn't want to write that.
Wait, so it's not like a rate of change, this is just saying what the population is?
No, that is the rate of change.
So, okay, so you're saying like it's decreasing by half, or it's like increasing by
It's increasing by
0.5?
500,000 aliens per year.
Okay, yeah, that makes more sense.
0.5 million. It told us in millions up there, so I just didn't want to write it. You guys are trying to make sense out of something strange though.
No, I don't know, I just feel like you wrote it weird.
Oh, okay.
Well, just cause it didn't say like it didn't indicate like a change, you know what I'm saying? I don't know.
Oh, if you ever see two different things being compared with that per, that's a rate of change. Because it's telling you how
Oh, yeah, I
fast
know
one
that,
number
it just
compares to
seemed,
the
I
other.
don't know, it just seemed weird.
Yeah, the whole situation.
I was just gonna say put a comma after year.
This one or that one?
The first one.
Okay,
Thank you.
go for it. Where I'm getting to is the ones that I always thought were kind of felt strange. We're now on the inverse. So, up here, the original function talked about the number of aliens that were on the planet this many years after discovery. What would the inverse stand for?
That many years after discovery.
5 years after discovery, at the 7.5 million population mark, was 5 years after discovery. It's, okay? The X and the Y stand for opposite now. Originally, this was time, population. Oh, wrong one. Time, population. The inverse, this is not the derivative, this is the inverse, is going to be population, how long it took to get to that population. So, the 7.5 million population. You're saying the same information, but saying it backwards. 7.5 million population was reached 5 years after discovery. And then we've got the bottom one, which is the inverse derivative. So now the label for the inverse derivative is going to be years per million of aliens. Because the label up here was aliens per year, this one is now going to be years per million of aliens. How many years did it take for 1 million aliens to come?
Wait, so the first one was like a rate of change, and then the second one was just like the set number? So like the second one isn't increasing by a certain amount after 5 years, it's just saying like at 5 years it was this
It's
number?
not like a scale.
Here's my. What? Is that what you're trying to ask me?
Yeah.
Okay, the derivative notation instantly means rate. The original function notation is just actual data numbers, not how fast it got. I basically just wanted to go through this section of problems because of how odd they are. What I want you to focus on is what the inverse represents. So it just represents that the two units are being read backwards. The one unit that's being plugged in is always called like the independent variable, which affects the dependent one. Yeah, Matt.
Oh, I was just gonna say, so it takes 3/4 of the year for 1 million aliens.
At the 7.5 million population mark.
Okay.
It's a piece of data that nobody would ever want to know, but that's what it's saying. The inverse, I don't want you to worry too much about. We don't focus on the inverse at all when we're doing our word problems, our related rates. You're not going to be asked to find the backwards information. Now, it's common and useful in certain, certain situations that once you decide on what you want to be to a career, right? Like, maybe you need to find out when it's gonna hit this mark, rather than finding out how fast it's currently changing. So, depending on what career you go into, the inverse might be useful. We're just kind of basically talking about what it stands for right now, but we won't be using it really ever. So I wanted to have these in the examples so you could at least just see how it's written, but not going to be common or used. Okay, that actually took longer than I was expecting just because it's so odd to write out. There really isn't anything different in the rest of the section. The whole section is about trying to get used to writing labels and saying what information stands for. And once that feels comfortable to you, then when we start doing related rates, it's going to feel quite a bit easier. So, that's it for 4.1.